Our project consisted of using integrals to define an experiment that deals with linear motion. The project was based on the Pinewood Derby, although we would only use one car, we would not race against others. We would try to calculate and measure the distance traveled, time taken, and speed by using integrals. It is a project that was pretty straightforward, although calculating the speeds was pretty hard. We used the ramp, which was 1.241 meters long and was elevated by a 21-degree angle. Its height was 0.45 meters high. The adjacent side was 1.62 meters long. We chose a blue Chevrolet Lego car as our test subject, which had a passenger in it. It totally weighed 0.125 kilograms, and we chose this car because we thought it had better traction, better tires due to the fact that they were rubber, and they had better steering. It went straight forward. It had a better direction. The energies acting upon the car will be potential and kinetic energy. The initial energy will be equal to the final kinetic energy. Since the potential energy will transform into the kinetic energy, there will not be any work done since the track gives a force that is always perpendicular to the car's direction. The potential energy will depend upon the height at which the car starts, and this time 0.5. Some of the forces that will be present that we will not consider will be those of friction and air resistance. Friction is the ratio of the force acting between the material surface to the pulling force. In our case, it will be rubber pulled by wood. Air resistance will not be as strong since the experiment took place inside a house. No high winds nor high speeds. If we did consider it, we will have to appreciate the car shape and loads of other stuff that we do not understand, and we rather keep it simple. Well, in this problem, I went to physics for help, since there aren't as many integrated formulas that use inclines, acceleration, mass, etc. So I used the acceleration on the x-axis formula, which basically was W, which is weight, times sine to the 21 angle over 0.125. That gave me that the acceleration on the x-axis, since there's no acceleration on the y-axis, there's no force acting toward that makes the car go up. So the acceleration on the x-axis, the total acceleration was 3.51 meters per second squared. And I got the final speed after 1.241 meters down the incline. So initial velocity was 0. The acceleration was 3.5 meters per second squared. The distance traveled was 1.241 meters. And the formula for final velocity was final velocity squared equals to initial velocity squared plus 2ad. A being acceleration, d being distance. So basically, I square rooted the answer that gave me 2 times 3.51 times 1.24. This gave me that the final speed was 2.95 meters per second. So here I tried to get the distance traveled by using integrals. I'm not pretty sure if that's actually the answer. According to my measurements, it wasn't. The distance traveled was about a meter and so. So yeah, I think I kind of failed using the integrals, but on the other hand, using the physics formulas, which may also be considered as some type of integrals, I did get most of the results right. So yeah. Firstly, I found the acceleration once again. I used the data I knew and a formula I had in my notebook.
but for a different problem. It was, we knew the final time was 2.95 meters per second. The time was 3 seconds, and the initial time was 0 meters per second. Here's the integral, as you can see. Then we got the acceleration, then we integrated the velocity formula, the formula we used to get the acceleration. We integrated that once again to get the position time formula. We integrated, we solved it, and we got, as a result, 4.42485 meters, which according to me was pretty wrong, but I mean, again, in this formula we do not consider the inclined plane nor the weight of the car, so yeah.